All right, one more logarithmic equation just to show you something else that could happen, and you can do this two ways. This problem says I've got the log base 3 of x plus 6 minus log base 3 of x plus 2 is equal to log base 3 of x. So this situation, I've got logarithms on both sides. Now, if you watch the two previous videos, I had logarithms on one side, a number on the other, and we used the definition. Now, you could put this problem in that format. You could subtract the log base 3 of x over here, get everything on the same side, and then use the definition of the logarithm in the exact same way. So if you like that method, use that method. But when there is logarithms on both sides, there is a slightly simpler method you can use. So first thing I'm going to do is I'm going to get on the left, I'm going to make that, instead of 2 logarithms, I'm going to make it into 1 logarithm. So this is a subtraction. So remember, that's the quotient rule. So that says I've got the log base 3 of x plus 6 over x plus 2. On the right side, I've just got that single logarithm. And now, just like when we first solved exponential equations where we could equate the bases, because the exponential function was 1 to 1, when the bases are the same, the exponents have to be the same. Well, the same thing's true for the logarithm. The logarithmic function is a 1 to 1 function. So if my bases are the same, which they are, then for both of these statements to be the same, that just means that x plus 6 over x plus 2 is equal to x. That's a property of the logarithm being a 1 to 1 function. So at this point now, I can solve this. We talked about rational equations last chapter. What I'm going to do first is I'm going to multiply both sides by the common denominator. So x plus 2 and x plus 2. And then we're going to solve the equation that results. So on the left, the x plus 2's cancel, and I have x plus 6. On the right, I have x squared plus 2x. It's a quadratic, so I'm going to get everything on the same side of the equation. So I'm going to subtract the x. So 2x minus the x makes x. I'm going to subtract the 6, and that's equal to 0. This factors. I think the rest of this is kind of old hat. You've done about 4 billion of these in your math lives. Then I have x plus 3 equals 0, x minus 2 equals 0. So my potential solutions are -3 and 2. So I'm just going to make sure, again, that these fall in the domain, meaning what I'm taking the logarithm of has to be bigger than 0. So let's try the -3. -3 plus 6 is 3. That's good. -3 plus 2 is -1. Uh-oh, we cannot take the logarithm of a negative number. So I'm going to throw that one out. Let's make sure the other one works, because you can have problems that have no solution. So 2 plus 6 is 8. Good. 2 plus 2 is 4. Good. 2 over here. All of those are positive values, so this is a fine answer, and my solution set is the set that contains the value 2.